Hey everybody, happy Friday. How's everything going? JB here with another CyberInsight live stream. Today we're going to be going back to another one of these Linux labs that we've been putting together. And today we're going to be talking about the most widely used remote access protocol that we use within Linux, and that is going to be SSH. So before we hop into that, kind of just to give you a little quick overview of what we're trying to do here, is a few different things. First off, if you just want to learn about Linux, then you're in the right place. That's kind of the main baseline of what we're trying to do. But then also, if you're trying to study for the CompTIA Linux Plus, or let's say like the Red Hat Certified Administrator, then this is a good jumping off place for you as well. So before we hop over into the lab, as always, help me out with these YouTube algorithms. Hit the like button, subscribe, all that good stuff. And as we're going through this, if you have any questions or comments, throw those into the comment section. We'll get to those, say hello to everybody as they drop in and all that type of good stuff. So I think the first thing that I wanted to do is kind of give you a little bit of an idea of what we're going to be doing in this lab. So we're going to do a little bit of a quick review over SSH and what it is. Then we're going to talk about using SSH keys compared to using usernames and passwords. And that's going to be primarily what the first lab is going to be covering, is how to go about setting up your Linux environment to be able to have a SSH server running, how to generate keys, and how to authenticate with those. Then after that, we're going to be going through and using a free tool that will allow us to look at the way that our SSH is configured on our server. The default configuration leaves a little bit to be desired there, so we always want to make sure that we are configuring that in a way that is most secure for the environment that you're in. And then if we actually do have any time after that, then maybe we'll talk a little bit about GPG, which is another encryption tool that we can use to actually encrypt different types of files and updates and folders and things like that. So if we have enough time, we'll get to that. If not, then we'll stick strictly to the SSH stuff. So yeah, let me hop over into the lab environment, and then we can go from there. So let me bring this up over here. And if this is your first time checking out one of these Linux labs that we're doing, I'm just using a free version of Ubuntu. You can go and download that and use whatever type of hypervisor you want to use on your laptop or desktop. I have a link for that in the description for the video if you want to go get the same exact version that I'm doing. So as I mentioned, just a quick recap on SSH and what it is. SSH stands for Secure Shell, and it is a way that we use to connect to different types of devices, whether it's Linux or Unix or network devices, and it allows us to remotely manage them. But the important thing with it, and why we like to use it, is all of the data that's sent back and forth is actually encrypted. So you might have heard some folks talk before about using Telnet or something like that, way back in the day. And the reason why we don't use that anymore is because the usernames and passwords and all the other data that we'd send back and forth, anybody who's kind of listening on that wire could intercept those packets and see what our credentials are. So SSH is the way to go. And it's a TCP protocol. So if you kind of followed some of our other networking topic videos before, you know that TCP means that it's a connection-oriented protocol. So it's a lot of handshakes and sending data back and forth, making sure that the data that's being sent back and forth is correct and received in the correct order. I'm trying to think what else is kind of important to hit from a high level. Talked about the fact that you can use usernames and passwords, or you can use cryptographic keys. And that's actually what we're going to be focusing on today in the lab, is how to generate cryptographic keys, just because that's going to be a bit more secure than using a username and password. And we'll just kind of go at it that way. Now, as far as kind of how that all works, when we end up setting up the SSH keys, it's as what's called a public and private key. So there's actually one that you keep to yourself, which is a private key, and then the other one, which is a public key, we end up putting out on the server that we want to connect to. When we go to authenticate using these, we have that key pair that's on our local machine, and on the remote server, as I said, we have the public key, and normally those go in the home directory under .ssh and authorized keys. And you'll see that when we create that we're going to actually copy that over into that file. And when a client connects to the host using the SSH key, it'll inform the server of its intent, and will tell the server which public key to use. The server then checks its authorized key file for the public key and generates a random string and encrypts it using the public key. This encrypted message can only be decrypted by the associated private key, which should be on your workstation that you're connecting from. Oftentimes when I've done this in an operational environment, I'll use a tool such as Putty or something like that, and we'll keep my private key there. The server will send this encrypted message to the client to test whether they actually have the associated private key. Upon receipt of this message, the client will decrypt it using the private key and combine the random string that is revealed with a previously negotiated session ID. It then generates an MD5 hash of this value, transmits it back to the server. The server already has the original message and session ID, so it can compare the MD5 hash and make sure that everything is good and copacetic, and they all trust each other at that point. So, main things to take away from that is public key, private key. Public key is going to go on the server that you want to connect to, and you're going to keep your public and private key as well on your host workstation. So let us actually hop over into the command line here. And just to kind of give you a little bit of a rundown of specifically what we're going to be doing in this lab, because there's going to be a whole bunch of different steps, and I think it kind of makes sense to lay these out from the beginning, and then you kind of understand as we go through it. So first thing we're going to do is install the OpenSSH server application onto the server. We're going to download that, and that's going to generate the host keys for the server automatically. Then we're going to generate a key pair for the user, and that's going to be granting myself access by creating the authorized key file that contains the public key, which we're then going to put in that SSH directory that I showed you on that website. Then we're going to get the server host key fingerprints, which we're going to use for verification when we go to connect. And we're going to use a caching tool called SSH Agent, and we're going to use our private key to that so we don't have to kind of go through this process every single time. And then we're going to connect over SSH, we're going to verify the host key, and we're going to permanently save the fingerprint for the server when we connect. And you might have noticed this before if you've ever done any type of SSH connections to a new device. You'll get kind of this warning message saying that you're unfamiliar with the fingerprint for the server. Do you want to save it? And that actually will end up saving it into a file underneath your user directory, so that whenever you end up coming upon or trying to log back into that same device again, it will already recognize the host key that was presented. All right, we've got a question coming in. We'll throw that up real quick. Should you use a separate key for every server or a single key? You're gonna want to use a single key. At least that's the way that I've seen it. So you're gonna generate that. You're gonna take the public key and you're gonna put it, wherever on whichever servers that you are gonna want to log into. Happy to be corrected by anybody else who does it any other way, but that's the way that I've seen folks do it in most environments. So let's hop into this. As I said, the first thing we're going to be doing was downloading and installing the OpenSSH server. So we're going to go sudo apt install OpenSSH server. And we're going to put in our password for that. And this is very similar to what we've done in the other Linux labs, which, by the way, if you haven't checked those out, I have a playlist on the channel so you can see all the different stuff that we've done. I think we've done network services and network troubleshooting. We've done creating users and groups. We've done managing and monitoring jobs and processes. So a bunch of stuff that you can use to try to start to get your hands dirty as far as understanding Linux stuff. So pretty good. All right, now the next thing that we're going to do is we're going to go ahead and generate the key for my user. One thing I want to point out with this, because we're going to have a few different options here. So it's SSH-keygen. So if we go and we take a look at this real quick. SSH keygen. You're going to see kind of up here at the top under T for type, we have a whole bunch of different types of encryption algorithms that we can use for creating our key. And it's important to make sure that we make the right decision with that. So I just want to take a second to kind of cover that. I'll get out of this and hop over to this website and kind of talks about the different algorithms that we have. So right off the bat, DSA, you don't want to do it. It's no longer supported. Don't even think of it as an option. RSA, you can use it, but it's recommended if you're going to use it to use, probably about a 4096 bit length when you're creating it. And that is an option that you have when you do that to specify the bit length for the key that you're generating. So you could go that route. But really, based off of everything at this point, the most recommended option is this ED 25519. And that's what we're going to do in the lab today. But I just did want to cover this because sometimes in some of the other labs that we've done, especially if you've been following the Pentest Plus labs, you've seen that some of the SSH stuff we've been looking at when we go and find people's keys and copy them and reuse them and things like that, that a lot of those have been under the RSA folder. So I just wanted to point out that in reality, if you are doing this, you really do want to use the strongest algorithm that you can at this point. So that's what we're going to do. So to create that key, we're going to go SSH keygen -T for type and ED 25519. And it's going to enter where to save it. And as you see, it's going to be my home directory under SSH. And we can go ahead and do that. And then we're going to need a password for this. Okay, so you can make this whatever you want it to be. Let's see. I'm going to do that. Enter it again. Okay, and then let's see what this is. Generating the public-private key pair. Enter file into which save the key. So that was where we were saying it was going to be under my home directory. Saved there. The public key has been saved right here. And there's a SHA-256 hash for the fingerprint. Cool. So what we do want to do at this point is we've created my key. And remember, I said that whenever we go to connect to these servers, we want to take that public key and put it into the authorized keys folder that's on the individual server. So we're going to go copy.ssh id 259.pub, and then we're going to copy it to SSH authorized keys. Okay. And there we go. So let us go. Now let's go get our machine's host keys. So we go SSH key scan. And the reason we're getting this is so that we can verify when we go to connect later on that the fingerprint that we're getting back from the host is correct. So localhost pipe SSH keygen -lf dash. Okay. Now we're going to want to save these bottom 3 lines. And you see that there's different fingerprints depending upon the different algorithm that was used. So I'm just going to take these and save these off for later. Okay. Now, the next step is going to be running the SSH agent caching tool and adding our private key to that. So we're going to go eval. Now, if you aren't familiar with what the eval command is, it's kind of a good time to bring that up too. Let's see. Eval is a built-in Linux command which allows us to execute arguments as a shell command. So we can kind of take different commands and combine them together as a shell command. So we're going to go eval, and we're going to go $SSH-agent. Agent PID is that. We'll go SSH add. And this is where I'm going to need that password that I created for my keys. And now my identity has been added into the SSH agent. It's going to cache my private key to the SSH agent. And so I don't have to type the password again during this session, but it's still going to maintain the security for it. So at this point, I should be able to connect. We're not going to connect to another server. We're actually going to connect to the same server. So I'm just going to go SSH localhost. Now, I should be prompted here. Like I mentioned, it's going to be unknown key. And this is the key that's coming from the server itself. And so if we take a look at this here, it should match one of these ones that we were looking at up here. And as you can see, here it is right here. So we do know just by looking at this that, you know, we aren't accidentally going to the wrong device or there's some type of man-in-the-middle attack or something like that. We verified with the hash that the fingerprint for this certificate for the device is correct. And then we're going to want to accept that, right? So we're going to say yes. And then that's going to add that into a file going forward, so we won't have to check this again. Now, if for some reason the device's certificate ends up changing, and this happens sometimes when you have maintenance on different types of devices. You know, since I work more on the network side of things, I see this happen quite a bit. You end up changing the cert on a device that's associated with the with SSH on that device. You're going to get a prompt saying, you know, the key's changed. You know, do you want to trust it? Or it's going to give you an error saying that, you know, you can't connect because it already has a different key associated with that IP address. At that point, you have to go into that file and remove the old key fingerprint. Okay. Now let's see. Okay. And we can see at this point, after doing that, then we are prompted with this, and we are now kind of SSH'd into ourselves. Let's go. We go exit. See, there we go. The localhost connection is closed. Should be able to do this again and not have to put in the password for the cert or anything like that. There you go, back in. So what we what we can do at this point, though, is we can go exit again. We can kill the process for the SSH agent, which, if you remember, we kind of did that. And go kill. I don't know that. I think this is. And see, by killing the SSH agent at that point, then that caching that I had done when setting that up no longer works. And we're going to have to enter this again, or enter the passphrase for the key to do this, which we can do. And there we go, and we're logged in again. So that's kind of the point of using that SSH agent, is to be able to keep those cached so you don't have to continually do that. So yeah, that was kind of the whole thing behind the SSH keys, creating them, using them, caching them. I'm trying to think anything else that's kind of important with that. I think, from a general perspective, low level, that's kind of, what that all consists of. Any questions on that before we move into SSH best practices? I'm going to take a sip of something here for a second. If we have no questions on that, then we can move on to best practices. So we're going to use a tool called Lynis. And I know it sounds an awful lot like Linux, and I think it's just off by a few letters, but it will do some type of automated checks as far as your configuration, and it actually can audit a whole bunch of different types of configurations. In this case, we're just going to be using it to look at the SSH configuration. So we're going to install that as well. Sudo apt install Lynis. We're going to do that. Let it do its thing. Now, something that's worth pointing out with this is it's going to be looking at the configurations that are in a config file under etc ssh sshd_config. There are some other things that doesn't necessarily cover that you might be able to pick up if you're doing like a Nessus scan. So for instance, I don't think that this really covers SSH algorithms as far as like your hashing or encryption algorithms and how strong they are. So that is another reason why it makes sense and is good to use a vulnerability scanner to kind of look at things also from an external perspective. All right, so that is all installed. We're going to go sudo Lynis audit system tests from group SH. Okay, so while this is running, let me kind of show you what it's doing here. This runs real quick. It doesn't take very long, and we can kind of scroll back up to the top and walk through everything that it's looking at. Okay. So if we scroll back up to the top, we can look at it's initializing, it's detecting a whole bunch of information about the system. And there's kind of some default profiles for what it's going to be trying to do. And there's a newer version that we could go and update, if we actually were going to be using this in a production environment. And it's doing some Debian checks for some plugins. Again, that's not really so much what we are too worried about. We're more interested in the SSH support stuff. And then looking at that SSHD config file. And it kind of goes down all these different options or different configurations. And if the default configuration matches what their recommended security configuration is, it gives you an OK. If there's nothing there, it gives you not found. And if it's something that they think could be hardened or configured a little bit better, then they give you a thing saying a suggestion. And then when we scroll down a little bit further, they're going to tell you what those suggestions are. So if we just kind of look at this off the top, kind of some things here, allowing TCP forwarding. So maybe they don't want you to be able to actually forward through an SSH tunnel, another protocol. Depending upon your environment, that might actually be the way that you manage different types of things. So actually, that's a really good point too that I was going to mention later, but I'll mention it here. Just because the suggestion here says that it doesn't match, what their recommended security configurations are, that doesn't mean that you should go and change everything to exactly what they recommend, because there are certain things that they recommend that actually will break things. And if you are doing TCP port forwarding and you go and you turn that off, that can cause you some issues. Or for instance, when we get down here and we take a look at the port, SSH defaults to port 22. Well, their recommendation is to use a port that's unfamiliar. Well, who in the right mind in an operational environment is going to change all their SSH ports to something else? I don't know that that really is going to get you too much, especially if you're still able to fingerprint stuff based off of the services. It just means that you move from port 22 to some random ass port number. But if you do that and you don't coordinate that with a whole bunch of people, you're going to break a whole bunch of stuff in your environment. So take all of these things with a grain of salt. I also would recommend, if you are actually using SSH, you're using Linux in any environment, take a look at different types of security baseline configurations that are out there. We've talked a little bit before about CIS benchmarks. We've talked before about DISA-STIGs. We've talked before about some NIST configurations. Take a look at those, see what they recommend for hardening as well. Most of the things that are in here will also be covered in those types of documents, and they'll give you a little bit more background on why you want to configure things in certain ways. So client alive count max. I think that's going to be how long your session lasts for, I believe. Let's see. Compression, whether or not you're using any type of compression. Your logging level, right? So if we go back and look at different types of syslog levels, how verbose are you being with your logging? Max authentication tries. So how many times can somebody try to connect to the device before the device tells them to go pound sand when they keep putting in the wrong password, right? Normally you want to cut off that session, maybe after 3 tries or something like that. Max sessions, that's another good one. You don't want to allow, 20 sessions into your device. Maybe you only want to allow 3 or 5, something like that. Permit root login. So that's going to be something where, do you want the root account to be able to actually connect to the device? That's a tough one. It really depends. You want to have some type of local account that has root privileges in the event that your centralized authentication fails. But you probably want to create that separately, and maybe you don't want to actually allow the actual root account itself with the username root to actually be able to remotely authenticate. Maybe you only want to be able to have that account authenticate via console, or once you've already connected with another account, then you can switch to that account. We already kind of mentioned the port, TCP keep alives, X11 forwarding, and allowing other types of forwarding. So if we kind of look down through the results, those are all going to be related to different software stuff. So I don't care so much about that. I want to see the actual SSH stuff. Okay, so consider hardening SSH configuration. So they're saying that the allow TCP forwarding is yes, we should switch it to no. The client alive count max is 3. They're saying switch it to 2. Compression is enabled. They're saying that we should change that to delayed or no. log level, changing it to verbose. Max authentication tries, going from 6 tries before it actually closes a session to 2. Max sessions, again, from 10 down to 2. Permit root login to no. This is saying they want you to change the port from 22 to anything. They're crazy people. TCP keep alives, change that to no, and some other things. So if we want to actually go and take a look at how we would go about modifying that, then we can actually go and take a look at that SSHD config file. So if we go and we're going to VI over to Etsy, SSHD config. And I'm going to do this and it's not going to work, or it won't let me edit it, I should say, if I don't sudo. So we're going to sudo. There we go. Okay. So in looking down through here, we see that all of this stuff for the most part is there. And as we talked about before, if you want to change this, there's a few different things that we could do here. We could actually save a backup of this if we wanted to. What I would do in this case is I would leave the default configurations with the # and then change whatever that config is underneath it without the # and that will become active. So we're not going to go through and change all of these different configurations because that would just kind of be pointless, but we'll change one. We'll save the SSHD config file. We'll restart the SSH service, and then we'll go and rerun that same Lynis scan again, and you'll see that it no longer comes up as an issue. So I don't know. Let me find one that I want to change. We could go the allow TCP forwarding, I think was one, or max sessions. Let's see. Max sessions should be up further back up towards the top, I think. Yeah, max sessions. Okay. So with VI, we're going to type I to be able to actually insert something, and then we type out what we want. Max sessions, and we were going to change that to 2, I believe was what they wanted. When you're done saving whatever it is that you want in here, we're going to hit oh, let me do that. Okay. I'm going to hit escape, :WQ# to save it. Okay, now we're going to restart the SSH service for SSHD. So we're going to go sudo systemctl. You should remember the systemctl commands when we were looking at starting and stopping different types of services. Reload SSHD. Okay. Now, let's go. We're going to verify that what I saved is actually in that config files. Let's go. Etsy SSH SSHD _config. And let's go back up to the top. Should be there. Max sessions 2. Yep. Okay. So now let's go and run that Lynis scan again. Let it do its thing. And then what we should see is if we go scroll up on that the max sessions now is okay versus before it had the suggestion. If we scroll down to the suggestions here, max authorize, max sessions was right in that same area and it's gone. So yeah, that is kind of it as far as looking at the SSHD config, running the Lynis tool to take a look at some suggestions for best practices. As I mentioned, you also want to run a vulnerability scanner against your SSH interfaces as well. It'll let you know if you're using some weak ciphers. That way you can go and change those as well. I think that is kind of the main things I want to hit on SSH. So using the certs, creating the certs, caching the certs, and then taking a look at best practices. I think we still got a little bit of time where we can hit up the other encryption tool that I was talking about before, which is the GPG stuff. If you guys are up for it, I think we can do that, because I think it's only maybe a little bit after 7:30. All right, so let's do that then. And as I mentioned, the GPG is used for encrypting different types of files, emails, software packages. It can encrypt, decrypt, and digitally sign. So you can do a few different things with that. So just kind of like with the SSH, you got to go ahead and you got to generate a key for it. So we're going to go GPG and double hyphen generate dash key. Okay. And in this case, we're going to pretend to send stuff back and forth between two people. So let's go Mike Scott. Let's go M Scott at dundermifflin.com. And that should be okay with that. We'll hit OK. Now we're going to create a passphrase to protect Michael Scott's key. Okay, and we see that that has been created. Then we're going to create another one. Let's go generate key. Dwight Schrute. And what did I do for Mr. Scott? M Scott D Schrute at dundermifflin.com. Okay. We're going to do a password for his stuff. Okay. And we have that there. So now we can take a look and see all the keys that we've created. So we could go GPG dash keys. And we can see based off of this, it's checking the TrustDB. There's 2 signed there. So we have 1 for Michael Scott, 1 for Dwight Schrute. Seems pretty straightforward. Let's take a look at cd dot GNU PG. Let's see. All right, so within the GNU PG directory, we got a few different things here, right? So we have a trust database right here, and we saw that that was mentioned back up in here somewhere. Yeah, checking the trust database, right? We have a public key ring right here. And then we have a revocation directory, and that's a directory for revoked certs. And then we have a private key directory containing the private key files, which is this here. And again, that's why we had those passwords for those. So let's go and try sending a secret message between the two folks. So let's go, we're gonna just go, we'll just echo some text here. Echo, I don't know, what would, hello Dwight. And we're gonna put that into a file we'll call secret. Okay, and then GPG, let's see, we're gonna send it to Dwight. So that R there is gonna send it to Dwight. So that should be Dwight Schrute. I might need to use some parentheses around here. I'm not entirely sure. Let me see. Let's see if that works. And then what are we sending? We are sending the secret file. Okay. And with me going to send that, then it wants me to enter my password to unlock the secret key to be able to use that to do that. So we're going to go, okay. Now, you should be able to find, if we go file, secret, secret GPG, and we see that it is a file that is encrypted. So if we try to open that up without using the password that gets associated with the private key, then that's not going to work. So we could go secret.gpg, and you see it's all garbled. It's no good if you don't have the public, or if you don't have the private key for the document that was signed with the public key. So so what we can do is we can decrypt it. We can go GPG-D for decrypt. Then we're going to go secret.gpg. And we can see that in doing that, then we were able to decrypt it. It was going to Dwight Schrute, and it said, hello, Dwight. So, so again, to recap kind of what we covered there, we had a file, we sent it from one person to another, we signed it, and then encrypted the file with the second user's public key. So we encrypted it with Dwight's private key, or with Dwight's public key. When we did that, the secret, just a regular secret file became secret.gpg, which was encrypted with Dwight's public key. Then when we went to decrypt it, we looked at the kind of header and stuff that came out here, and we were able to decrypt it with his private key. So that's kind of how it works. Something to mention here, I guess, is in a real world scenario, we would be importing keys from either a third party directly or from a public key server, and then assigning them trust values. Within GPG, trust values kind of deals with, how much do you trust this person to properly verify someone else's key before signing it? So yeah, that's kind of GPG in a nutshell, kind of a easy default way within this to be able to do different types of encryption and sending it back and forth between folks that have public and private keys. So I think that is pretty much everything that I wanted to cover today. Let's see. So does anybody have any questions or anything like that before we wrap up? We talked about SSH Best Practices, and using GPG for encrypting, decrypting, and hashing files. So if nobody has any other questions, then we go ahead and wrap this up. Hope everybody has a great weekend. Go get at it, and yeah, we'll talk soon. All right, bye.